we are learning how to multiply square roots, and in another video, I'll show dividing square roots. Let's do a quick investigation. If we have the square root of 4 times the square root of 9, when I do this, it's basically the mathematical symbols show me that I should take the square roots first. So let's do that. Square root of 4 is 2 times the square root of 9, which is 3, and that equals 6. But what happens if I, for whatever reason, I didn't know what this number was, if I multiplied the numbers inside the square roots first? So 4 times 9 is 36, and the square root of 36, hey, that equals 6 too. So what's cool about this is that we find that if you have two numbers inside the square root, that's the same as taking the square root of the first number and multiplying it by the square root of the second number. And you can do this either way. If you have this right side, then you can decide to multiply the stuff inside first, or you can decide that you want to take the radical of each number separately. Either way, whichever suits you. What I love about this rule is that you can essentially just do whatever's easiest for your brain, and I love stuff like that. With dividing, it works the same way. So the top is going to be the square root of a, and the bottom is the square root of b. And what this means is that I could either divide first or I could take the square root first. And remember, these rules can be used in both directions. The reason why it's called the product property versus the quotient property, product, remember, means the result of multiplication, and quotient, remember, means the result of division. Let's go ahead and do some examples where this will help us out a lot. I'm going to do B. Now, first, let's look at our directions. They say simplify using product properties of radicals. Now, if it said approximate, that would mean decimals, but simplify means that we don't want any decimals. We just want to write this as a radical form, but simpler. So no decimals. If you have decimals, you are doing these ones wrong. Let's go ahead and do B real quick. Okay, so the square root of 6 and the square root of 18. Before, when I showed you that example, I knew what the square roots were because it was a perfect square. Neither of these are perfect squares, which is a bit of a bust. So we're going to multiply them together first. And then at the end, we need to write it as in simplest form, so we're going to simplify. So I'm going to multiply 6 times 18, and I don't actually know what that is. Let's find it out. 6 times 18, 108. Now this is fun because a lot of my students, when they do this, they'll be like, I don't know what two numbers multiply to get 108. Frequently because the number is actually way bigger than anything in our times table, so it's usually bigger than 108. Here's the deal though, you just multiplied two numbers to get it. So if you were to make a factor tree of this, you'd write 6 and then 18. So can I edit this a little bit? Since we're going to simplify at the end anyway, why don't we just not figure out what that number is? Like, why plug it in my calculator if I don't have to? Why don't I just write that this is 6 times 18 and then move on? So I'm going to write that it's 6 times 18, and then I'm going to complete my factor tree from there. So here's 3 and 2. This one's 9 and 2, and this is 3 and 3. Now I'm going to rewrite these simplified in my radical. Let's put all my 3's together. 3, 3, 3. 3 times 3 times 3, and then all my 2's together. Times 2 times 2. All right, we're going to, every time there is a pair, that number goes outside. So there's a pair of 3's, so I have 1 3 outside. That 3 doesn't have a pair, so I'm going to leave it inside. There's a pair of 2's, so that goes outside. Now what I have left is 2 times 3, which is 6, and on the inside I have 3. Well, that was pretty easy. You might not have even seen the first step, but you can tell that we multiplied the numbers together first. Let's check to see if we got the right answer in our calculator. You should be able to get the same decimal for both your answer and the original problem. So let's put the square root of 6, and then you have to be careful. You have to move it out of the square root, times the square root of 18. Okay, I get 10.39. Okay, and then we wanted our answer, which was 6 times the square root of 3. 6 times the square root of 3. Oh, I got the same number. So that tells me that this is a simpler version. This is a simpler version of this. So, and the radical is all the way simplified. I know that because it's 3. So it's the correct answer. 6 times the square root of 3. Final answer. Okay, now what happens if we throw in some multiplication in there? Okay, whew. I think what's really important to note here is you have to think, is a number and its square root equal? Those are different things. The square root of 3 is actually smaller than 3. It's about 1.7. So here's the deal. You cannot multiply radicals with things outside of radicals. That's kind of the point of why we wrote it like this. But you can multiply things that don't have radicals together, and you can multiply things that do have radicals together. So you don't have to do this step, but I'm going to show you kind of what we're thinking. Because of the commutative property, we can rearrange all the things that don't have square roots together and all the things that do have square roots together and multiply those things together. So let's multiply these two together. That's going to be 6. And then let's multiply these two together. I don't know what 3 times the square root of 27 is, but remember, I don't have to because I'm going to simplify it at the end anyway. So let's just write 3 times 27. Now I happen to know already that 27 is 3 3s because it's 3 cubed because I know my cubes like that. So I'm just going to write those 3 3s in there. And you say, wait, Miss Jobe, there's 4 3s there. Well, there should be because this one's 3 3s and then this one is one more. So we should have 4. Now let's go ahead and simplify our radical. I'm going to have 2 3s, 1 3 outside. 2 3s, well, I can't put it over there, so I'm going to put it over here because I can do that. It's multiplication. Now, the numbers outside, I have 3 times 6 times 3. Let's go find out what that equals. 3 times 6 times 3, 54. And I get 54. Now, inside, there's nothing. When everything simplifies out of the radical, that means it was a perfect square, and you took the square root. You simplified it all together already. So when everything's gone, you don't need a radical. You're done. Now, you could do this in a lot of different ways. You could simplify the square root of 27 first because you don't want to multiply as much, and you'd still get the same answer. The big points that you should remember: you should only multiply radicals with radicals and things that don't have radicals with things that don't have radicals. So that's the first thing you should remember. The other thing that you should remember is that at the end, it should be in simplest form. So simplify. And then here's another thing that you don't necessarily have to remember, but comes in handy. You can always check your answer by plugging this into the calculator and seeing if you get the same number that you got at the end. So on this one, I don't even have to plug in 2 different things. Let's just plug in 3 times the square root of 3 times, I forgot what number it was, but we're going to do it. 3 times the square root of 3 times 2 times the square root of 27. I got 54. Woohoo! So that is the correct answer, and we are done. Good luck and enjoy.